'Tis I, your friendly neighborhood math tutor and physics tutor. Uh, and whatever else I might know. Hello. How's everyone? I know, right now I'm talking to just the pod, but hey. I don't know. I still feel friendly, even to the camera. Hi, camera. How you doing? Do you guys ever go out of your way to be nice to your electronics? So, like your computer, your monitor, your phone. Because, like, if technology ever becomes self aware, you want them to be able to look back at you and go, you know, they were nice to us when they didn't even know if we really were conscious or not. Okay, we won't terminate them. They were cool. I don't know. That's something that I do. So it's okay. So I keep gushing about the streamer, but that's because she's awesome and you should go watch her. So the streamer Nyanners. Her last day of streaming is Friday, and then she takes Saturday, Sunday, and Monday off. And when she comes back on a Tuesday, she always talks about how, like, even though she's been streaming for, like, over 6 years, and she's been doing it professionally for over a year, she still gets, like, super nervous whenever she has to get back on Tuesday. Like, she has never streamed before. And I could never understand it. But now that I've been doing this for a few months now, taking Wednesday and Friday off, I was actually getting nervous to turn this thing on. I was like, oh my gosh, I'm going to be talking to myself and sounding like an idiot. And I guess at least I have the luxury of having just myself to talk to, and also my family doesn't mind that I'm insane, because they already know. But man, it's real. I guess moral of the story is trust people when they say things to you sometimes. Now, Thursday's stream. I had a really good time. That was actually really fun. Made some drawings. Reconnected with people that I hadn't seen in like forever, which was really cool. That was really awesome. And we actually hit our follower goal. If you look down there, I had to bump it up. Because not only did we meet our follower goal on Thursday, we went past it. Now again, yes, I fully understand. 21 followers is a drop in the Pacific Ocean. You know, streamers that are getting like a few hundred views, who have like a few hundred people watching them at one time, they can have like 10,000 followers. So this channel only has 21. However, or as Iron Mouse would say, however, comma, for someone who, I guess I'll be honest, for someone who has as little faith in myself as I do, getting to just 10 followers who weren't people that already knew me in real life was significant. So yeah, even though there might only be 21 of you right now, to me, that's not a quote-unquote only. There's 21 of you. And I just have to sit and think about that. You know, yes, a follow is like putting a penny into a Red Cross bell ringer's bucket on Christmas time. Even if you're not a Christian, still, it's like donating to a charity is not bad. It doesn't cost you anything to follow. But it kind of links you to that streamer, and you have to get notified when they go live, and you're like, I'm not that person again. But really, 21 of you looked at this channel and were like, you know what? Yeah. I'll vouch for this person. I'll say, you know what? They're worth watching. They're not bad. And that's really cool. That really is. It also doesn't hurt that, like, my end goal... Well, I guess I don't really have an end goal? But, like, my fantasy dream moonshot is to make this into a non-profit that is able to provide tutoring to people all over the planet through streaming services, so that you can access, like, people in very rural and usually poorer communities, so that they can get just as good of an education as people living in a big city. Or for, like, rapidly developing cities that usually end up having giant ghettos kind of built around them. Like, I think in Sao Paulo, Brazil, they have, like, a massive part of their city that's full of people that aren't as well-to-do. So they might not necessarily have the greatest of choice of schools to go to for their kids. But, like, with how the internet and internet accessible devices are getting, relatively inexpensive, so that even people that don't have much might be able to have, like, an older model smartphone. They could hop on the internet, watch a Twitch stream of a tutor in a subject that they need to learn from, speaking in a language that they understand, and is interacting with their chat so that that person can ask questions and get help. They don't have to sub, they don't have to donate. All they have to do is just have an internet accessible device. And then they can be given one of the greatest things that you can give any human: an education. That pie-in-the-sky dream that I have, it has to start somewhere. It doesn't just materialize out of nothing. So really, all 21 of you down there, yeah, there might only be 21 of you. But you have to start somewhere. And every additional follower puts us closer to making a universal free tutoring service a reality. Even if it's just one follow. One tiny little, like, baby step, little inch closer to a goal that's 10 miles away is moving us closer to a goal. So really, And heck, you know what? If 21 followers is all this channel ever gets, you know, I still feel like all of you have done a good thing. Because we have been able to help at least someone. Probably at least 4 people. Like, with actual math questions. Who may or may not have been able to get access to a tutor where they live. So, you've already done a good thing. And, like, even if you're only coming in here to watch the gameplay, by giving this channel support, by watching me fumble through 20-year-old games, really, you're doing a good thing. Like, you have, even if it's only indirectly, helped people. So yeah. I've just been thinking about it since the Thursday stream when we passed our goal. I'm happy about that. And hopefully... And here I am bearing my soul, and then over my head... Ah, majestic, soaring through the sky. Indeed. The majestic pee-pee poo-poo. Where was I? Oh yeah. So yeah. Oh my gosh, and I have now been rambling for like 14 minutes. Oh well. And also rambling to myself. But hey, the video will be up, and also I'll upload it to my YouTube. So like, if anybody watches it, then, yo, what's up? I see you. High five. Okay, I don't really see you. That'd be very weird. Okay. Well, except for the FBI agent that's watching me. Yo, what's up, man? Or woman. Or some other gender identity. They, them. How's it going? Okay. So, gushing time over. Now it's time to get really serious. Super serious. So this past week, I decided to start talking about probability. And the starting point for most probability classes is learning how to count. Now, I'm not talking about, like, oh, if you see 3 Skittles on a table, you count, oh, there's 1 Skittle, 2 Skittles, 3 Skittles. I mean... "100%. That is my prediction. With a confidence interval of 105%. I like those offs too. Okay, I will take back the ooh. Hello, Hunted. How you doing? As long as you're not driving, then awesome. If you're driving, stop. Oh, and I hit my mic. Oopsies. Okay. Wait, really? Oh. Living the life. I have never had a massage. Like, not a professional one, anyway. Huh. Although I am kind of scared, though, because, like, so I live in Arizona. Trying to live life, yeah. And we have, massage parlors? But they're usually located in strip malls. And they look kind of shady. And apparently, they're fronts for sex traffickers. Yeah. So, I have avoided them. There's one next to a pizza place that I like to go to as well. And just kind of looking at the clientele, I sometimes wonder, are there underage migrant kids that are working in there? Ah. Yeah, see, that would be a lot different because, like, you can see what they're doing. Wait. Wait, I don't think I've seen that word before. M-A-L-L. What's a mal? Is that something you can... Is it like a virus? Like malware? Also, that's a joke. I am ancient. I know what malls are very much. Although I'm not as ancient as you. You beat me by about by a couple years. But yeah. As promised, though, I I will actually talk about probability. I bet you that's a play on words, and I applaud you. Alright, man. Drive safe. Wear a seatbelt. Don't, drive like people playing American Truck Simulator. You know, because dying is not fun. Believe me. It's not fun. Whoops. That was the void. I didn't want to go there. Oh, come on, paint. Okay, there we go. So, starting off with probability, we talked about counting. But again, not just like counting a number of like things that are sitting on your table. We were talking about counting the number of different outcomes that could happen when you perform some sort of experiment, like flipping a coin. For any kind of experiment that is like flipping a coin, where the first coin flip and the 50th coin flip are exactly the same. Nothing has happened to the coin in between all those coin flips. It's still the same coin. Still has a heads and a tails. You could get strings of results, like all heads, or all tails, or alternating heads, tails, or tails, heads, or literally anything in between. You can count all the different outcomes that you could have when you run your experiment, flipping a coin a certain number of times. And I probably should have had my paint window, like, open, and my pen ready to go. But the number of outcomes, so... It's not the sample space. I'll call it capital U for, like, universe. Standing for the total number of outcomes that could possibly happen with your experiment. Your total number of outcomes would be A raised to the power of n, where A is the number of coin faces. So for a coin, n equals 2. But for a d6 dice, so your standard dice that you would play like when you're playing Monopoly, that would be n equals 6, because each dice roll for a d6 could have 6 different outcomes. You could have the 1 dot facing up, the 2 dot facing up, 3 dot, etc. So A stands for the number of coin faces, so either heads or tails, or just all the possible outcomes that could happen. And N is the number of coin flips. Okay. So, for any experiment where it doesn't change from coin flip to coin flip, in quotes, so every dice roll, every actual coin flip, every game where you take a ball out of a bag, but then you put the ball back in the bag, where it's just being repeated the same thing over and over, this is how you can count all the number of possible outcomes that you can get. Now, for probability, the probability of an event happening equals the number of ways event can happen divided by our U, or all the ways that anything could happen. This equation for probability works not just for, like, experiments that are like coin flips. It works for anything. Our equation for the number of total ways things could happen will change. It's not always a to the n. A to the n only applies to experiments that are the same trial after trial. But for simplicity's sake, we're only going to talk about coin flips for right now. So, we've explained how to get one of the key numbers for finding the probability of an event happening when you're dealing with coin flips. But we haven't necessarily talked about this top part here. Well, actually, we did. It's the number of ways an event can happen. that was when we were talking about a concert with a certain number of time slots. So, like, if you had 5 time slots that you had to fill in your concert, and you had 5 bands that were going to play, and every single one of these bands was going to play, they were contracted to do so, then your first time slot has 5 choices. So then if you select a band, then for your second time slot, you only have 4 choices of bands. So then you make another selection. And then you make a selection, so now your 4th time slot has only 2 possible choices. You make a choice, so then your last time slot, it's just going to be the leftover band. If we started a diagram of all the different timelines, so all the different possible realities of arranging the schedule of our concert, for our first time slot, we would have 5 different possible starters. We could have started with A, we could start with B, we could start with C, and we could start with D, or E, or U. But then, once we select a band, then we only have 4 choices, so 1, 2, 3, 4. So if you picked A, then you have to select either from B through E. If you picked band B, then you have 4 choices. 2, 3, 4. So A, C, D, E. If you picked band C first, then you have 4 choices after that. So A, B, D, E. And sorry that the diagram's getting really messed up. It just kind of happens. And it's totally not because I'm terrible at drawing. So then you could have A, B, C, or E. And then if you started with band E, then you have 4 outcomes after that. So A, B, C, or D. And then, for your third time slot, you've already selected 2 out of the 5 bands, so then there are only 3 more bands to go. So you could have selected a band, or band, or band. So we have already picked A and B, so then C, D, E. For this combo, B, D, E for this combo. And again, yes, I'm painstakingly going to draw this entire diagram, but it's so that I can show you guys why you count all the different ways you could rearrange bands in a concert the way that you do. So then A, B, D. Okay, so then you pick A, you pick D, well then that means you have B, C, and E left to still pick for your third time slot. But if you pick E second, then you have these guys. So you would have B, C, and D there. Okay, so I'm not going to draw out all of the branches here, but just know that each one of these guys will have 3 branches of their own for their third time slot choice. So this is for the first time slot. This is for the second time slot. This is for the third. So then for our fourth time slot, we've already selected 3 bands, so then there are only 2 choices left. So from here, we would have 2 choices. And from here, we would have 2 choices. And from here, we would have 2 choices. So if you went A, B, C, well then you could do D or E next. If you went A, B, D, you could use C or E next. If you went A, B, E, you could go B. Or A, B, C, A, B, C. And I feel like I've screwed something up. A, B, D, C, E. A, B, E. I already wrote B, and I wrote B twice, so that's not supposed to be B. That's supposed to be D for duh. C, D. There we are. Okay. And then again, each one of these would have 2 branches of their own. So then, once we've selected 4 bands, then there's only 1 band left. So if we've already picked A, B, C, and D, that means we can only pick band E. If we went A, B, C, E, that means band D is the next one. If we went A, B, D, C, then E would have to end it all. If we went A, B, D, E, that means C would have to go. A, B, C, D, E. A, B, C, E, D. Okay, so we swapped them. A, B, D, C, E. And EC. Yes, okay, good. So then in here, we just swap them like so. Okay, so this is 4th time slot, this is 5th time slot. If you look, going from not scheduling anybody for the first time slot to choosing somebody for the first time slot, we have created 1, 2, 3, 4, 5 branching outcomes. Once we have selected somebody for the first time slot, then each start of these branching timelines will have 4 of their own branches for the selections for the second time slot. So going from choosing A first to anyone else, we've added 4 more outcomes. B gets 4 more outcomes, C gets 4 more outcomes, D gets 4 more outcomes, E gets 4 more outcomes. So that would be 5 times 4. Because here there are 1, 2, 3, 4, 5 outcomes. For choosing somebody for time slot 2, so then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 different timelines just for selecting somebody for time slot 1 and then somebody for time slot 2. So there are 20 different outcomes. And you can see why it is 20, because you have 5 groups of 4. And that's what multiplication is. So this would be 5 times 4, right here. And then for each selection for the second time slot, they have 3 new branches of possibilities. So if you finish drawing this entire diagram, and then counted all the different possible results at the third time slot, you would see that there would be 60 branching outcomes. Well, that's 5 times 4 times 3, because if you look, there are 3 outcomes and the third part. And then going from the third time slot to picking somebody for the fourth time slot, there are only 2 choices left. Nice! Was it doing your lawn business? And either way, very nice. I like that. That could go to Microwave Fund. Okay. So, since the fourth, going from third to fourth, each starting point in the third time slot gets you 2 more results, there would be 120 different finishing branches at the fourth time slot, which would be 5 times 4 times 3 times 2, because going from third to fourth. Oh! Is it because you don't need a bike anymore? And then for the fifth time slot, since it's just the leftover band, there aren't really any other choices. Yep. You were growing up. I was just thinking about electric scooters, mainly because I think I want an electric scooter. But also, there are Vespas? But I live in a place... Well, actually, Ohio has god-awful weather. Arizona has god-awful weather, too. So it's like, it's almost always better to have an enclosed vehicle so that you don't, like, get to your work or school smelling really bad. But yeah, going from the fourth time slot to the fifth time slot, there was only one choice you could make. So then you don't get any more branches, so there's still going to be 120 branches at the very end. That's 5 times 4 times 3 times 2 times 1. That right there is 5 factorial. And you got an old push mower. Now, when you say push mower, do you mean it still, like, runs on gas or electricity? Or do you literally mean it's just like a cylinder blade and you have to roll it back and forth to get it to go, and then you just start walking and it cuts the grass? Ah, okay. Gotcha. Because I've had one of those kinetic push mowers. And they're a pain in the butt. They suck. So yeah, that's nice that you have a motored. Yeah. But yeah, so when you're arranging bands for a concert, or essentially just rearranging a set number of things, like rearranging these 5 bands into 5 time slots is the same as saying take the first 5 letters of the alphabet and just find all the different orders that you could write those letters. It's the same question. It's just take the number of things that you have and factorial them. That's how you can count all the different ways you can rearrange things in a list that you can tell the difference between. So we had talked about that before, but I wanted to really illustrate why it's a factorial. Why I went, oh, it's 5 times 4 times 3 times 2 times 1. You can use a timeline diagram to help you see how many ways things are going to happen, and thus see why the equation we get is what it is. Now, we also talked about rearranging the letters in the word Mississippi. And an example that I gave was like a concert where we had a certain number of time slots, but not the same number of bands to perform. So bands could go more than once in our concert. But they were going to play the exact same set. They weren't going to play different music from one time slot to another. You know, so if you had Guns N' Roses playing more than once, and their first song was Sweet Child of Mine, then the next time that they played in that concert, they would still start with Sweet Child of Mine. Finding out all the different ways that you could... Yeah, Guns N' Roses. I love that band. Finding out all the different ways that you can rearrange bands in a concert where bands will repeat. Welcome back! You successfully drove and didn't die. That's great. It's the same as taking the letters in a word and finding all the different ways you can rearrange the letters in that word, but you have repeated letters, and you cannot tell the difference between the repeated letters. So, like, the word Mississippi. Okay, the I's I'm just gonna make dashes. Miss-ippy. Yeah. Mississippi. Delete. Whoa, what the heck? Okay, I am slowly losing my ability to control my hand. Alright. M-I-S-S-I-S-S-I-E-P-I. If you look, there are 11 letters in this word. Why am I just drawing dots? That's very stupid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if I were just to write the first 11 letters of the alphabet, A, B, C, D, E, F, G, H, I, J, K, so the first 11 letters of the alphabet, and I asked, okay, how many ways are there to rearrange the first 11 letters of the alphabet? The answer would be 11 factorial, which is more than 39 million. So we're not going to spend time drawing out a tree or a timeline diagram for all the ways that we could rearrange the first 11 letters of the alphabet. It was already a hassle to rearrange the first 5 letters of the alphabet. If we had done the full drawing, we would have had 120 finishing branches, and I'm not going to do that because that is dumb. But if we wrote out a tree to track all the ways that we could rearrange the first 11 letters of the alphabet, our tree would have over 39 million end branches. But what about a word like Mississippi? Where, if you look, you actually only have 1, 2, 3, and 4 different letters in the word. They just happen to be repeated. Will there be over 39 million different outcomes of rearranging the letters in the word Mississippi? Let's make our lives a little bit easier. We've already rearranged all the letters in the first 5 letters of the alphabet, and we got 120 different results. Sorry, I had to converse with a fellow human in real life. Okay. So we've already rearranged the first 5 letters of the alphabet, and we found that we get 120 different results. Let's rearrange the first 5 letters of Mississippi. So, M-I-S-S-I. Missy. And we'll actually draw a diagram for that. So we have 1, 2, 3, 4, 5 letters. And the letters that we could choose from are M, I, S, S, I. Okay, let's say I chose this S. Or this S to go in my first box. Does it make any difference if I chose the first S or the second S? When they're the exact same letter S and there's no way to distinguish between them? No. There is no way to tell the difference. Second block, M-I-S-I. Is this S from here? Or is that leftover S from here? Do we know? Can we tell the difference? No. Okay. Well, okay, let's choose a letter I next. But here's the thing. Will we be able to tell the difference between this letter I and this letter I for this time slot? Probably not. So, I'll just write this in alphabetical order now, just to really illustrate. Because, like, I wrote the letters in order, but really, they didn't have to be written down in a specific order. So, I am S. Okay, which I went here? Was it that I, or was it this one? We don't know. We couldn't tell the difference. Okay, so then let's pick our letter M. Now, there was only one letter M. We could tell the difference between M and all the other letters. Sorry, I hit the mic again. We could tell the difference between the letter M and all the other letters. But we don't have this ambiguity. But we have this ambiguity when we have repeated letters, because it's like, well, which one did we pick going from our first option to our second option, or from our second option to our third option? Who knows? IS. In this choice, so at our third choice and our fourth choice, we don't have ambiguity on which letter we chose, because we don't have repeated letters anymore. Every single option to choose from is distinct. So then, if I pick this, then I only have this left. Okay. Now, it looked like I had 5 different choices to go with. But right off the bat, I couldn't tell you whether or not I chose the first S in the word Mississippi or the second S in the word Mississippi, because the letter S is the same no matter how many times you write it. It's just the letter S. So does it really make any difference if I chose one S or the other? Do I really have 5 possible starting results for choosing the first letter in the rearranging of the first 5 letters of Mississippi? When there's ambiguity, instead of 5 distinct results for our first letter, really, there's only 4. We could have gone with M, we could have gone with I, and since we couldn't tell the difference between one S and the other, we might as well have just written one S instead of 2 S's. And then going into our next selection of letter, so we went with S for our first letter. Because there were 2 S's, we could still, let's see, choose another S if we wanted to. So we could choose another S. We could choose an M. We could choose an I, and we could choose an I. But, wait, here's the same problem. we can't tell the difference between the top branch for the first I that we could choose, and we can't tell the difference between choosing the bottom I. So really, we should have made our diagram like this. So, M, I, S, I. And then, for the S's, we could have chosen an S, we could have chosen an M, or an I. And then if we chose an I, we'd still be able to choose another I, because there are more than one I. And since we only chose an S, we could choose another S. And then we could have chosen... Let's see, so... Here, we could have had two I's, that's fine. We could have had two S's, or we could have had our M. But my very first branching, I'm ahead to a friend's. Hey, have a good time, man. Good to see you. Glad you made some money. Have fun with your friend. Also, make sure your friends don't headbutt you in the knee. You seem to have a habit of hanging out with friends that like to hurt your knees. So just make sure they know, don't hit your knees. But yeah, take care, Brandon. So, in my first selection of a letter, and when I'm rearranging the first 5 letters in the word Mississippi, I can't tell the difference between the I's either. So, I shouldn't even draw that. When I'm rearranging the first 5 letters of the word Mississippi, instead of giving distinct starting selections for all the letters in the first 5 letters of the word Mississippi, since I can't tell the difference between the I's, and I cannot tell the difference between the S's, then instead, for my selection of my first letter to rearrange the first 5 letters in the word Mississippi, I should only have 3 branches for my total possible outcomes. I could have chosen the M, I could have chosen one of the I's, and I could have chosen one of the S's. Now, if I chose an M, I still have 2 I's to choose from, but I'm not going to write 2 branches for those. I'm only going to write 1, because I wouldn't be able to tell the difference between them. So only 1 branch for an I. If I chose M, I could have also chosen an S. Now, if I chose I have an I that I could still go through. I could have chosen one of the 2 S's, or I could have chosen the M. Note how we don't have the same number of branches from our starting picks. If we start with M, we only have 2 distinguishable second outcomes. But if we start with I, we have 3 possible outcomes that we could tell the difference between. It's the same story with S. If we chose S, we could go with an I, because there are 2 to choose from. We could go with the letter M, because that hadn't been chosen yet. And we could go with the other S. So there are 3 outcomes after choosing S first. Now, If we chose M and then we chose I, how many different outcomes are left? There's still an I to choose from. And there's still two S's that we could go with. If we chose M and then one of the S's, we still have two I's left over to choose. Or we could have picked the last S remaining. If we chose both of the I's, well, there's still an M to go. And there's still both the S's to go. If we chose an I and an S, well, this guy has three different possible outcomes. Because there's still an I, there's still the letter M, and there's still an S to go. For this M, well, now there's only two options. You could have chosen the last I, or one of the S's. If you chose S and then I, this has three options that could happen. You could have selected the last I, the M, or the last S. If you picked S and M, you could have chosen one of the I's or the last S. And if you chose S and S, then there's only two different outcomes. You could choose one of the I's, or you could choose the M. So see how the drawing is already more complex? Not every next step has the same number of possible outcomes after that. And the reason why is because we can't tell the difference between related, repeated letters. So it collapses the number of options that you have to choose from. Now, if we chose M, an I, and then an I, then all the I's are gone, and the M is gone. So then here, there really is only one more option. You could have chosen an S. If you chose M, I, and then S, well, now you have a couple different choices, because there's still an I left over and still an S left over. So you would have an I or an S to go with. If you went M, S, I, there's also two outcomes left. You could go with the last I or the last S. If you went M, S, S, well, now there aren't any S's left over. And you already selected M, so then the only letter left over is an I or an I, but you can't tell the difference between the two I's, so there's only one branching outcome there. If you selected an I and then an I and then an M, then there's only one branch, because it's just the two S's left over. If you selected the two I's and an S, well, now you have two possible outcomes. Because the letter M was still on the table, and there was still an S to go. If you went I, S, I, that also has two outcomes. The I's have been all selected out, but there's still an M, and there's still an S. If you went I, S, M, this has two options as well. And again, sorry that the drawing is so bad. It's something where I have to visually show you to really convince you that the equation that I'm going to write down is the way it is. Okay, so I, S, M. I could have chosen an I, or I could have chosen an S next. And if I went ISS, then there are still two choices. I could have gone with an I or an M. Okay. And long story short, if you keep playing this game, so we've done it for the first, the second letter, the third letter, and a fairly good portion of the fourth letter. You know what? I'll just finish up the fourth letter. It's going to be ugly, disgusting, but who cares? I care. So if you go IMI, that one has only one option left. It could go with one of the S's. If you go IMS, well, now you have two choices because there's still an S and an I on the table. If you go SII, you still have two options. You could go with the M or the last S. If you go SIM, SimCity, then you have two options because there's still an I and an S left over. Oh, that's an S. Hello. Okay. If you go SIS, then you have two options because you can go with an M or an I. If you go SMI, then there are two options because there's an S or an I. Good lord. Almost done. If we go SMS, now this one has only one option. You could have chosen one of the I's. If you go SSI, there are two choices because you could pick the last I or you could pick the M. And then if you go SSM, well, that one only has... Ugh. I screwed that up. That one only has one possible outcome, one of the I's. Okay, almost done. If you go MIIS, then there's only one more outcome, the last S. If you go MII... Nope, if you go MISI, then there's only another S to go. If you go MISS, then you have to go with an I. If you go MSII, then an S. And essentially, since it's the fifth pick, there's only one letter that's left over, so each one of these things only has one branch remaining. So you can see how writing out your branching timelines can be really time-consuming and tedious. The only reason why I'm doing it right now is to illustrate a point. So let's count all the different ways there are to rearrange the first 5 letters of the word Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Okay, now 30 end results is a pretty good amount. But remember, if we were just rearranging the first 5 letters of the alphabet, we would have 120 different possible outcomes. But with this example, we really were just rearranging the first 5 letters of Mississippi. So, in rearranging the first 5 letters of the alphabet, A, B, C, D, and E, we found that there was 5 factorial, or 120 different ways to rearrange those letters. But for the first 5 letters of Mississippi, M-I-S-S-I, we found that there were only 30 ways to rearrange those letters, because you had repeating letters. You know, you had 2 I's and you had 2 S's. So there really were only 3 distinct starting options to choose from. So we could have gone from an we could have gone to 5 results. I-S-S. But we can't really tell the difference between these 2 I's, so we would just get rid of one of these branches. And then we can't really tell the difference between the 2 of these S's, so we'd get rid of another branch. So you can see the outcomes from here and here would be identical. You know, if you picked I, well then you could have picked one of the S's. You could have picked the M. You could have picked the other I. You could have picked an S or an S. But another thing is that you can't tell the difference between the S's, so you wouldn't have drawn this second line for the S. And then for this I, it would have been looking exactly the same, because you could have chosen an M, you could have chosen the other I, you could have chosen an S or an S. But again, you can't tell the difference between that second S, so you would get that branch gone. So when you have indistinguishable entries in your number of things that you are going to rearrange, you notice that you're getting an identical version of outcomes per thing that you can't tell the difference between. So if I were going to rearrange the letters A, B, B, and then C. So A, B, B, C. If you started with an A, well then you can choose an A, or an A, or a B, or a B, or a C, but it's the same for this dude. You could choose A, B, B, or C. And it's the same for this dude. If you picked A, you could choose A, B, B, or C. So you get these identical paths, but you can't really tell the difference. So, right off the bat, you can see, instead of having 3 distinct starting paths, we only have 1. When you have repeated entries, so again, like here, you take the total number of things and you factorial it. That'll tell you all the ways that you could have rearranged those letters if they were all distinguishable. And then you divide it by the by the number of things that you could not tell between. We were going from 3 distinct paths with their own branches to just 1. Well, going from 3 to 1 is dividing by 3. But we also could have, quote-unquote, rearranged these 3 letters in our orders. So really, it's 3 factorial that we're getting rid of. And then for any other entries that are repeated, they will also be multiplied and go on the bottom. So since there are 2 B's, and we could have rearranged them as well, we're getting rid of one branch. So that's dividing by 2. And also, we could have rearranged these B's. We're divided by 2 factorial. So in this toy example that I just made, it would be 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 2 times 1. 2 times 1, dead. 3, dead. 2 will go into the 4. So you're left with 6 times 5 times 2, which is 60. Now, 6 factorial is bigger than 60. We know that 5 factorial, because we've already computed it, is 120. Well, 6 factorial is just 6 times 120, because it's 6 times 5 factorial. So that's 720. So we're going from 720 possible outcomes to only 60. The reason being, instead of writing out individual branches for your repeated letters, you just write 1 for that letter. 1 for that letter. And 1 for that letter. And from here, you could have picked an A, again, because there were 3 to choose from, but you can't tell the difference between which A. You could have picked a B, and you could have picked a C. For here, it's the same. You could have picked an A. Since there are 2 B's, you could have picked a B or a C. Here, though, you've already picked the C. There was only 1 of them. There are 2 A's left over, but you can't tell the difference, so you only make a branch for 1. And then there are 2 B's. Well, there are 3 A's, but you only make 1. For B's, just a B. If you picked 2 A's, there's still 1 more A to go, and then there's still 2 B's to go, and you could still pick C. If you picked A, B, same story. There's still an A to go, there's still a B to go, and still a C. If you go A, C, well, now there's only 2 possible ways to go. You could pick an A, or you could pick a B. If you went BA, that has 3 outcomes. A, B, C. If you went BB, well, now all the B's are gone. I don't know why I drew 3. So you could go with one of the 3 A's or the C. And if you went with BC, okay, this has 3 outcomes. A, B, C. CA, okay. Only 2 possible outcomes. You could have gone with an A or a B. CB, okay, you could have only gone with an A or a B. Since we picked all 3 A's, then there's only 2 outcomes here. One of the B's and a C. If you went with 2 A's and a B, you have 3 outcomes here, A, B, C, yada yada yada. Draw it all the way out, you'll see that you get 60 results. The equation works, and you can use this diagram to help verify to yourself that, yes, this really is what happens when you are trying to rearrange things that you can't tell the difference between. So for MISSI, 5 letters, so it would be 5 factorial, but then divided by 2 factorial for the repeated S's. There are 2 of them, so it cuts down the number of branches for your first pick from an S and an S to just an S. And then it also considers that you could have rearranged the S's, so that's why it's 2 factorial. And then 2 factorial times 2 factorial again for the repeated I's. So then you get 120 over 2 factorial is 2, and 2 factorial is also 2, so 120 over 4, which is 30. So long story short, to rearrange a list of things, the total number, or our total number of ways, which I called U like nearly an hour ago, is equal to the total number of things that there are, so n, but then divided by the things that are indistinguishable factorial. So category 1 factorial times category 2 factorial times ... till you get to category however many indistinguishable things there were. So the number m is the number of distinguishable repeated groups. So for our example of MISSI, little m would equal 2 for the i's, and for the s's, they're repeated, they have more than one entry, but we can at least tell the difference between i's and s's. So that's what the number M stands for. The C stands for number of times that entry repeats. That's not how you write time, unless you're going THY and E. Number of times that entry repeats. So again, for MISSI, for the red S's, C would equal 2. And N would be total number of entries. So for MISSI, N would equal 5. So this is the way to rearrange a list of things, whether or not they have repeated entries. It doesn't matter. So, we are now essentially on our way to creating one of the most basic, and yet also one of the most useful probability distribution functions. Essentially, a function where you tell it a certain condition, and it tells you the probability of that condition. Okay. So, to reiterate... No, don't save. We had a U for coin flips. And again, that's figurative coin flips, where it was A to the N. A meant number of coin faces, and N meant number of coin flips, and then you had the total number of ways to rearrange a list of things. And we said that was n factorial. Come in. Why? Yeah, I can do that, but when? Yeah, but when? I usually am done by 7. Okay. Okay. Things are still good. I'm going to keep streaming, but I'm going to have to make sure that I am absolutely done by 7, at least. Because I have to go get dinner for everybody. So yeah, if anybody's watching, help me to remember that in essentially 2 hours, I have to go. Okay. For the good of my family and everyone in it. Okay, and so for the total number of ways to rearrange a list, that was this equation. C2 factorial times dot 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 times C sub m factorial, where n was the number of entries in list, m was the number of distinguishable repeating groups, and C was number of times an element repeated. So we have these two equations right here. We can now calculate the probability of flipping a quote-unquote coin a certain number of times and getting heads a certain number of times. So let's say I wanted to flip a coin 4 times. We'll go ahead and draw our branching timeline diagram. So it could be heads or tails for my first flip. And then, since it is an experiment that's the same from one coin flip to another, one trial to another, if I get heads, I'm still going to get either heads or tails. Nothing crazy there. So still going to get heads or tails. And then I can still get heads or tails if I got heads, and I could still get heads or tails. Same here. And then same here. And then here. And here. Okay. We could count how many different ending branches there are, but essentially we already know that it's going to be the total number of results for our coin flips is going to be a to the n. A was our number of faces. Well, with an actual coin, there are only 2 faces, heads or tails, so that's 2. And we flipped it 4 times, so to the 4th power, so that is 16. So we know that there are 16 total possible outcomes when you flip a coin 4 times. There are 4 ways, there are 16 ways that you could flip a coin 4 times. Now, let's choose an event. Let's say our desired event is 4 flips and get only 2 heads. Well, instead of only, a better word would be exactly. Because you might interpret only to mean 2 or less. If I say exactly, then you know what it means. It means just 2. Wow, that's a weird why. Well, if I'm flipping a coin 4 times and getting exactly 2 heads, I know that if I just list the outcomes together, it would be a pair of heads with a pair of tails. Now, the different rearrangements of this, I could count. I could go, okay, here's the timeline where I get a head and a head. Okay, then everything else has to be tails. So that would be 1. I could go head, head. Well, and that's it. I could go heads, tails. Heads, tails. So that could be the second outcome. Or I could go heads, tails, tails, heads. That's the third possible outcome. Or I could go tails, heads, heads, tails. So that's the fourth. Or I could go tails, heads, tails, heads. That's the fifth. Or I could go tails, tails, heads, heads. And that's it. That's the sixth. Or I could have used our equation to count all the different ways to rearrange. We have 4 total entries. 2 heads, 2 tails. So 4 factorial on the top. But then we have 2 groups that are repeated. We have the H's and the T's, the heads and the tails. And both of them are repeated twice. So it'd be a 2 factorial on the bottom, and then another 2 factorials. 2 factorial times 2 factorial. So this would be 4 times 3 times 2 times 1 on the bottom, over 2 times 2, which is 4. 4's divide out, so we have 3 times 2 times 1 is 6. Ah-ha-ha! See how that's coming together. So we have the total number of ways to have a desired event occur, getting exactly 2 heads when you flip a coin 4 times. And we also have a number for the total number of ways that you could flip a coin 4 times. So the probability of our desired event of flip 4 2 heads would be the total number of ways that you could flip a coin 4 times on the bottom, and on top, the number of ways you specifically get your desired event. 6 out of 16. Since probability is a ratio, we don't really care about what the actual, total ways on top and total ways on bottom were. We care about the relative size of those numbers. We care about their proportion. Proportions, fractions, you can reduce. So we're going to do that. Both of them are divisible by 2, so 6 would turn into 3. 16 would become 8. So our total probability of flipping our coin 4 times and getting exactly 2 heads is 3 out of 8. So you have a 3/8 chance of flipping a coin 4 times and getting exactly 2 heads. Now let me think about that just for a moment. So we could go that, heads, tails, heads, tails. Yep, heads, tails, tails, heads, tails, heads, heads, tails, tails, heads, tails, heads. Okay, so tails, tails, heads, heads. Yeah, okay. If you look at this probability, this probability of getting exactly 2 heads is the same as the probability of getting exactly 2 tails, since we flipped the coin only 4 times. But you might be thinking, wait a minute. If my coin is fair, then I should have a 50-50 chance of flipping my coin and getting a heads or a tails. And so I'm asking the question, like, I'm flipping my coin 4 times, and I'm saying, okay, I want half of the results to be heads. Or half of them to be tails. Then why aren't I getting 1/2? Why aren't I getting 4/8? Why am I getting 3/8? It's because we're not doing one trial, not one experiment. We're repeating the same experiment over and over. And so you can get results that you might not expect. But by writing out your tree diagram, you'll see that that really is the case. And if you ran an experiment where you flipped a coin 4 times, for thousands of times, and you took the average number of heads divided by 16, you would get a number that gets closer and closer to 3/8 for your chances of flipping a head 4 times and getting exactly 2 heads. Now, instead of having to write out a tree diagram over and over and over again, there's a function called the binomial distribution function. Where you have the number of times that you flip your coin, and I shouldn't plug in numbers just yet, and the probability that your coin is going to give you a specific result. And it goes like this. N Oh, there are 3 things that you need. Right. Delete. You have to have your number of coin flips, the number of times your specific result appears, and the probability of that event. And that is n, choose m, p raised to the m, 1 minus p raised to the n minus m. Now this may look like a mouthful, but I have shown you a lot of this stuff before. This symbol right here, that is n, choose m, which we have seen in the binomial binomial expansion theorem. If I have, say, an a plus a b raised to the nth power, then we have a function that helps us write this out. Raised to the n, choose m, a to the m, b to the n minus m. This is essentially like binomial expansion. Like, it's not a coincidence that they look very similar. And then to calculate n choose m, which I've already shown you, is n factorial divided by m factorial, n minus m factorial. And yeah. So, I didn't really say what the probability of getting a heads or a tails in one trial was. Did I? I just said that there were 2 possible events for each trial. I repeated the experiment 4 times. So I got 6 results where I got exactly 2 heads out of a total of 16 total events. Now let's say that I bring probability into this. So not only do I have 2 results that could happen, a heads or a tails, I also introduce the notion that I am equally likely to get a heads or a tails. If I flipped a coin 1,000 times, I would expect to get 500 heads. So for my coin, for most, like, you would assume that it's the same chance to get either heads or tails, so the probability is 0.5 or 1/2. Almost always use fractions when you can, because they make computing stuff a lot easier. So if we're still going to do the number of coin flips as 4, so... and the number of heads we're going to get as 2, then our binomial for 4, 2, and the probability of 1/2, we would get 4 choose 2, 1/2 raised to the 2, and then 1 minus 1/2, 4 minus 2. Simplifying that a little bit, you got 4 choose 2, 1/2 squared. Inside this parentheses, 1 minus 1/2 is a half. This stands for the probability of getting our heads, because we had asked the question, well, what's the chances of getting exactly 2 heads when you flip a coin 4 times? This right here is the chance of getting tails. Your probability of getting heads or tails should equal 1. They're equally likely, so they should have the same fraction for the chances of happening. So that's why both of these dudes are a half. And then 4 minus 2 is 2. So then we can simplify some more. 4 choose 2. 1/2. Since these guys have the same base, they're both base 1/2. Their exponents will just add together. So 1/2 to the 4th power. 4 choose 2, we can actually write out what it is. It's 4 factorial over 2 factorial 4 minus 2 factorial. And we know that this number is 4 times 3 times 2, all over 2 times 2, so that's a 4, so we get a 6. And then 1/2 to the 4th is the same as 1 over 16. And so this number right here turns into a 6 times 1 over 16. So 6 over 16, 3 over 8. That's the binomial distribution function. Instead of having to write out our massive diagram and all that junk, we just have a quick formula where we can say, okay, I want exactly this number of heads out of this many coin flips, and the chances of getting heads is this. And really, it is just... since we're talking about literal coin flips, it would be the number of flips divided by the total number of repeated things. So, how many times heads repeated times the number of times tails was repeated. Whoops. Yeah. So, like, if I flip a coin 5 times and I get 2 heads, well, then I have to get 3 tails. So, n would be 5, m would be 2, n minus m would be 3. And since the tails are indistinguishable, that's why it would be 3. And you could have rearranged them, so it's 3 factorial. Remember how that was the number of ways to rearrange stuff in a list? Divided by the total number of ways things could happen, we have A, which was our number of faces. So in this case, since it's a literal coin, A is 2, raised to the nth power, because n was the number of coin flips. Instead of writing somebody divided by somebody, I can write it as somebody n minus m factorial times that somebody and right here, that is n choose m. So we have found n choose m out of just the number of ways you can rearrange a list of things where you could have repeated entries. One can be raised to any power, so we could have a ghost n sitting here, which means that we could have had a 1 over a to the n instead of 1 over a to the n. And if you look, with an actual coin, a is 2. So for an actual coin, 1 over a becomes 1/2. That's the probability of rolling a Huh? Well, hi! Thanks for joining Diego Lima. My name is Blairg. Free math tutor. When people aren't asking questions, I just talk about random math stuff. Thank you for joining. If you happen to have an actual question, like right now, feel free to put it in chat. If not, keep watching. I'll keep talking. And also, getting any kind of tutoring is free. You do not have to be a sub or a follow... Speaking English is hard sometimes. You don't have to be a sub, you don't have to donate, and also I don't have 90 followers yet, so I wouldn't be able to accept money anyway. But yeah, thank you for the follow, I really appreciate that. Okay, where the heck was I? Oh, yeah. So then 1 over a, for an actual coin, would be 1 over 2, and 1/2 is our probability of a fair coin. So, that's where the binomial distribution function comes from. At least for fair coins. So, tomorrow, I will talk more about the binomial distribution function. And how to deal with coin flips that are not actual coins. So like rolling a 6-sided dice, or taking a ball out of a bag and then putting the ball back in. And that's something that we will cover later, tomorrow. Right now, though, we are going to jump straight into Silent Hill 2. So, yeah. Also, Diego, if you are still here and you're interested, I have a YouTube channel that I upload my VODs to, so like if you're particularly interested in... Hey! What's up, EA? Also, hello, Kotai Penguin! I'm doing well! How is everyone? I think I saw you, Kotai, when I hopped into EA stream one time. Awesome! But yeah. Oh! Well, we are talking about the binomial distribution function, which is a fancy way of saying if you flip a coin 15 times, what are the chances of getting, like, 6 heads? The binomial distribution function is the thing that tells you that chance. even if the coin is not a fair coin. So, like, if you have, like, a 1 in 3 chance of getting heads, it'll be able to help you out. It's really cool. I love it. But yeah. Yeah, exactly. And the fun thing... Yes. Probability, for anybody that doesn't know, is the foundation of statistics. Which I will get into in the future, especially since that was my major when I was... my latest major while I was still in college. I went in for physics, and then I realized I really liked math modeling more than, like, the actual physics. So yeah, I'll end up talking more about this in the future. But yeah, for Diego, who just now followed, like a couple minutes ago, I have a YouTube channel where I upload my VODs. Now, my internet is very limited, so I have to compress the videos a lot, so the quality is going to be kind of... But they will have whatever mini lectures that I give when no one's asking questions at the very beginning. So if you want to learn more about the binomial distribution and, like, the build-up from, like, the very beginnings of probability, those will be on my YouTube channel. But they're also here. Because, like, I started the topic, I think, on Wednesday. Or maybe Tuesday. Yeah, I think I started on Tuesday. But yeah. Yeah! Essentially what I'm doing right now. But not like formal structured lessons and whatnot. Because my ADHD is too strong. So I much prefer to, like, just bounce around different topics. So I give, like, a lecture to eat up time when people don't have questions. And then I play video games just to kind of give people something to do, again, when there are no questions. And also kind of get attention, because it's like, not as many people are going to jump into a stream when all you're doing is just talking about math. I wish that was the case, but it's not. And I do hope to turn this into a real functioning nonprofit that gets tutoring to a lot of people, meaning that it's going to be more than just me doing this. So I gotta kind of, like, popularize the notion of a virtual tutor or teacher or whatever that you can talk to for free. Yeah. So, like, if I can get this channel big enough, here's what I've been thinking. Number one, get the channel big enough that I can actually accept financial donations. So, like, subs and bits. Oh, that's what I have been doing! Like, this whole time. Like, so if you go to my YouTube channel where I upload my VODs, the beginning of every VOD, is on a subject. So, like, it's my entire stream, so, like, they range between 2 and 4 hours. But, like, the first, at least, hour is me just going through a topic at a level that somebody with basic algebra knowledge could follow. Because, like, that really is essentially my goal. Is to show humanity that, yes, you can understand math. Because it was a tool invented by humans. So, unless you have a severe developmental disability or brain injury, and I have tutored people who have had disabilities and brain injuries, and yet they were still able to pass like algebra classes because they worked their butts off, and I was very proud of them. Uh, like, but like if you're just your typical human, you can understand math. Just like how you can read. But yeah. Hello? Yeah, I see the similarities. Ugh! Oh! Thank you! It's really funny because, like, when this VOD goes up, like, even when you're not an affiliate, so when you still have below 90 followers on Twitch, they will still save your streams up to 14 days. So if you watch the beginning of this stream, I actually was gushing about how guys like EA helped me get this channel up to over 20 followers. And how in every little way y'all are helping to make something really cool and good for humanity happen. Cross fingers. I would show you me crossing my fingers, but my arms don't move. So yeah. Oh, sorry. Okay. I realize now that I need to move the alert box so you can actually see my face. Oh! You didn't. You don't have to do that, but I appreciate it. Thank you. I'll still say it though. Ramen is it Ramen Gemma or Ramen Gemma? Because I'm actually kind of interested how you pronounce your name. But yeah. Oh no, not your actual name. I mean like the account name. So a hard G. G. Ramen Gemma. Okay. Alright. Which is actually really funny because, like, the letter G in Latin is always G. Okay, well now you have to tell me about that because I don't know. Like, I actually don't know what kotai means. Ramen I know. Because you can eat it. Shoot, I forgot what I was gonna say. Oh yeah, I was gonna play Silent Hill. For at least an hour. Because then after that, I have to go get dinner from my family. Para mi familia. Oh, and, like, if anybody that, needs tutoring, Ramen Gemma. My love of ramen and Gemma is supposedly Japanese for gamer. You know, video games. Exactly. Well, I mean, if you're following EA, I would assume that you like video games. It'd be kind of weird to watch a gamer like EA playing video games when you don't like video games. Like, unless you just really like his company, which is also very possible. But yeah. Man. You know what's really weird? I am not used to getting more than one follow a week. But, like, what? We started today with 21. And so now we have 3 follows in just one day. That's ridiculous. But yeah, thank you. What the heck? Yes, I was gonna play Silent Hill. Yeah, see, my ADHD is like really bad, and I'm being treated for it too, and yet I still get lost. Kotai Penguin equals love the Metal Gear series, and the main character is Solid Snake. Yep, trained by Big Boss. Okay, and my favorite animal is the penguin. Ah. Yeah, see, my name was just, clear your throat, or make a noise of disgust. Oh, really? That's really cool. Now, were you able to live there long enough to have memories of it? Or was it like, oh, good? Because, like, I was born someplace other than where I currently live. Ah, yeah, it's the same with me. I was born someplace else, but we moved after 2 years, and so I don't remember a thing. Uh, but yeah, that's really cool that you at least get to say that you were born in Japan. Uh, okay, I rebooted. There we go. So let me get into our game room and then boot up Silent Hill. Uh, and also I'll be streaming my schedule for anybody that's wondering. I have it in the panel on the farthest right under the screen, where it says schedule, but also in the normal Twitch schedule tab. I just realized every day, 3 p.m. Pacific till about 7 Pacific. At least I try to do that. Both my wife and I have it in. Yeah. I happen to not have the hyperactive type. Like, it's just I get sidetracked very easily, but I don't have any energy. So it's like, I'm not annoying, but I'm also not reliable. Which is part of the reason why I don't think I would ever be good as being like a teacher. I'm more just, I have like random bits of knowledge that I vomit out, and then people can grab the vomit and then put it inside their own mouth and swallow. And why am I saying this? Okay. Well, thank you. That's very nice. Yeah. Okay, enough about vomit. Let's actually play Silent Hill, because I've been saying that like a million times. So say goodbye to the Diablo 2 soundtrack. We love you. And let me boot up Silent Hill 2. uh, and it makes me laugh because like a lot of people are playing Resident Evil 8. Uh, thank you. I I'm just gonna be positive and say it will happen. Like it will become a thing. Uh, because why not? I didn't like. I've been able to get to 20 followers. You know, and it wasn't just me. I've had a lot of help, but like, it happened. You know, so I think this might actually become a real thing. Okay, there's that. There's this. Oh yeah, welcome to the void, as I call this place, because I didn't bother to put a background. Also, I like the look of the black screen where you're just like in space, where there is nothing, not even sound. Hmm. Hmm. Good, nothing. There we go. Okay, so you see that. Na-na-na. Yes. Oh, that up. And of course you can't see it, but that's okay, because I can fix that. Properties. Here it is. Done. And there we go. Dude, the fact that I have eyeballs is awesome. Thank you. And the fact that EA, like, raids me fills me with glee. Because he does not have to. It's really awesome of him. I appreciate it. Yeah. Okay. All centered, all ready to go. And I just realized I don't have my controller. Ah! Okay, hold on. 1 sec. My model's gonna go all crazy, so... No, I'm not possessed, I'm just getting my controller. Uh-oh. Aw, man, There we go. Alright, put the stylus pen away. Oh, I guess we'll let the intro play.
James, honey, did something happen to you?
Massive.
After we got separated in that long hallway?
Yes.
Are you confusing me with someone else?
But I'm like the food critic from Ratatouille?
You were always so forgetful. Remember
Oh,
that
yeah.
time in the hotel?
Crossing fingers, Kojima.
Maria?
You said you took everything, but you forgot that videotape we made. I wonder if it's still there.
How do you know about that? Aren't you Maria?
Sorry about the volume, I just realized that I hadn't turned it down, in the stream audio.
I'm here for you, James. See? I'm real.
Not right now. Now you're dead. Yeah. Okay. So, catching anybody up who hasn't been following, that lady in the red jacket, Maria, she's dead now. She got stabbed. And now we are at the Silent Hill Historical Society. The town has been slowly going to hell. And I think really scary things are ahead. Even though, like, really scary things have been happening this entire time. Yo, welcome back. How dare you have a life? I am ridiculously offended. But yeah, how did you like the raid, the raid notification? Was it fitting to your majesty? Wait, what's this? Did I miss this? Liar? There's the thing right there. What? Hey, wait, hold on. What? Alright, whatever, fine. Through the door we go. Oh, I remember this song. There's nothing useful written on them. What do you mean? There's something... Whatever. A photo was hanging here. Brookhaven Hospital, 1880. This hospital was built in response to a great plague that followed a wave of immigration to this area. It was originally little more than a shack, but it gradually grew and grew. Huh. Who is that? Photo director of the old Brookhaven Hospital. It looks like he was a famous person in town. Huh. There is a photo of a deep, deep hole. What could this be? Who knows? What about these books? I do not want to go in there. Okay. Wait, what is this? Okay, I can't click on that at all, so I'm just gonna walk down the scary staircase. Oh my gosh, Ali! Hi! I thought... I'm sorry. I'm using this ghost overlay chat. Go deep in the hole. You cannot tell me what to do. You're not my dad. But I'm gonna go in the hole anyway. But, like, my chat overlay, both you and EA's names are in purple. So, when I just glanced down at chat just to see if somebody said something, I just saw a string of purple, and I thought I had answered EA. I didn't realize that there were more people. Hello! Also, if you listen, this sounds an awful lot like a boat horn. And we are going really deep. And we're going really deep beneath the lake. And, like, we've been told through other lore snippets that there are a lot of people that are buried beneath the lake. And also, there was a ship that sank in the lake that killed, like, 60 people. So... yeah. Yes. And we're actually like 9 hours in, and I haven't really been playing very fast. Deep, so deep. PG-13! Come on! Okay. Oh. When I first played this game, like this part, like I almost had to turn off after I was done. What is... Hello? Some kind of document is lying here. September... Oh no. This game came out before September 11th. Oh, that's a coincidence right there. September 11th, 1820. Prisoner number C221. I can't read the rest. What is this? I'm probably gonna write this down. So... 9/11, 1820. So... Come on, pen. There we go. 9/11, 1820... Prisoner... C221. Yes, James, I know. There's something of interest that you're looking at. Give me a sec. I have to write something down. Okay. Oh! Oh. Oh. But they wouldn't have known, like, it takes a long time to develop a game, so that little piece of written info probably was done before September 11th. Oh, geez, my favorite? I think my favorite's Silent Hill 3. I think the scariest one is Silent Hill 2. This game just is so scary that it's almost painful. But like the one that I like to play the most is Silent Hill 3. Yeah, talk about freaky for me when I played. Yeah. Uh-oh. I don't like not being able to move the camera. Where are you? Oh, jeez! We came out of the shadows and I freaked out. Okay. Oh. Okay. What's this? Oh, geez, this is a door that actually opens. What is that noise? What's this? Oh, handgun bullets. Okay. Oh, and more pictures! Oh, let's look. Okay, that looks like a train. Photos hanging here. Never mind, it's a bunch of buildings. Toluca Prison Camp. Built during the Civil War, later became Toluca Prison. Huh. What about here? A photo is hanging here. Oh. Okay, that is people being... Yeah, I wonder what's that noise. It just reminds me of The Grudge. death by skewering, and execution at the prison. Death by skewering or strangling. To choose as death is the prisoner's last taste of freedom. Yeah. Whoa. Crimson and white banquet for the gods. Alright, so that's signs of the cult. Well, do it! I bet you people would watch if you played through Metal Gear... if I had a functioning tongue. I bet you people would watch if you played Metal Gear Solid. Yeah. Oh, okay, so that's just busted. Cool. So I went through that door. And here's the hole. Can't see a bottom there, can ya? The hole's dark and I can't see anything. Will you jump down? The grads say that when they hear a noise. Oh! Oh, like the... Oh, yeah, okay, I get it. I get it. Do I jump down? Yes. I'm not a coward. And I jump down with just a steel pipe. Ah! Oh! And we're not injured in any way. Huh. Hold on. It's just a wall. It would be impossible to climb this. Wait, hold on, what did he say? Just a wall. Huh, this is different. Just this spot here feels different than a normal wall. I wonder if I could somehow break it. Oh? Buff James. Alright. Where are you? Come here, friend! Hello! Die. Poor guy. I'm like a mugger. Give me your wallet! Oh. Okay. So, I guess this is nothing. Skipping through the water. I guess this is the only way to go, so I'm gonna go this way. Wait a minute. There's a door over here. And a camera angle that I can't. I don't like the fact that that door is open. Wait, I can walk all the way over. What the? Oh, I just realized, the hall is vertical now. That's not an item, that's a fluorescent light. Right there. Just like the fluorescent light at the bottom right. Oh, this is trippy. Oh, I don't... ooh. Yeah, I don't like that. Yes, I see the obvious key, but, like, are they gonna do something mean when I try to go get it? Probably. I got the spiral writing key. Wait. Why did my flashlight go out? No! 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 No. No. No? No? I'm... No. No. Um... Um... This is bad. Nope, that's the pause button. So a dry cell battery got in the hospital room. Just an ordinary dry cell battery. I bet you that's something that I put in the flashlight, because I haven't had to use it at all. Key with the SIM 3-inch long cylinder attached. The cylinder is engraved with spiral writing. Okay. Radio's on, but my flashlight is dead. Wait, hold on. Is this thing out of batteries? It won't light up when I press the switch. Okay, so... Wait, how many are... Oh, that's rifle. Did I miss the rifle? I will be so sad if I miss the rifle. Okay. Well... Ah! No! Ah, let me out! Let me out! Stop. Oh, they don't stay dead. They're not staying dead. They're not staying dead. Oh. Now, I have more handgun bullets than entire military? Military? So let's see if this will work. Ah. Oh! You're right, you're right, you're right. Oh, I only used 8 bullets, so... Yeah. Alright. James, look at the numpad. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So 3, 7, and 9 are highlighted. Was that correct? Ah, crap. Alright, alright, alright. I thought maybe the prisoner number would be used, but no, you literally just had to put 379. That's all. So, how's everybody doing? Just a room full of invincible bugs that you can't kill. You know, nothing out of the ordinary. Also, thank you, A, for pointing out that there was a number pad. What? Better now that you're out of the room. Wait, hold on. Oh yeah, that's the body of the dude we killed. Okay. Huh. Imagine not grabbing the battery. They would not let you do that, right? I cannot imagine. Okay, so I think we have to go through the cattywampus hallway. But what do we do? Wait, hold on. There's a door at the bottom, and the door is locked. Okay. Door at the bottom, door is locked. You don't have to use the key, though. Oh, and there's the door. Because it just it uses keys for you. Ah. Okay. It's pitch black beyond the door. I can't tell how far the blackness stretches. Will you go down? Yes. Wahoo! Garen! Hello! How are you? Caught us at the perfect time. We're just continuing Silent Hill to, we are, oh geez. I wasn't expecting to find him.
Killing a person ain't no big deal. Just put the gun to their head. Pow.
You killed him?
But it wasn't my fault. He made me do it.
Calm down, Eddie. Tell me what happened.
That guy, he had it coming. I didn't do anything. He just came after me. Besides, he was making fun of me with his eyes, like that other one.
Just for that, you killed him?
What do you mean, just for that?
Eddie, you can't just kill someone because of the way they looked at you.
Oh yeah? Why not?
Because they weren't
now
sick.
I always let people walk all over me. Just like that stupid dog. He had it coming too.
Eddie?
I was just joking, James. He was dead when I got here, honest. Anyway, I gotta run.
You're going out there alone?
Yeah.
Eddie?
Huh? What am I looking at? Oh, that's what I'm looking at. Oh, and there's a tray of, I guess, just... Oh, I bet you we're in the prison. I'll drink. And it's kind of funny that we meet Eddie in a prison. Tablet of Gluttonous Pig. Huh. It's a picture of the prison, of the cafeteria. Alright. I'll drink. No, it's just a food tray. Okay. Is there anything else? Except for this dead guy. It's a corpse. The body is marked with bullet holes. Uh-huh. Wait, really? Huh. So, like, in the bottom right corner of the picture. Okay. Kotai? Heck no. No. I am not playing in a dark room. I am playing in a well-lit room, and I have family members that are awake and walking next to my door. I am... No. I used to be able to do this when I was a kid. I can't anymore. Yeah, no. 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 I don't know. For some reason, the older I got, the more of a wimp I got. Okay, just making sure. So that's the door we came through. And so... Wait, hold on. Stop. Okay. Marco! Ooh. Got some bullets. They've got nothing to do with me, though. Oh, there you are. Oh, great. No. I'm so good at this game. No, I'm not. Blackboard. Whatever's written on it is all faded and I can't read it. Okay. Yes, so there was a door here. This game had me petrified for the longest time. Nope! Yeah, it's not an easy game to play. Alright, so he's behind me. Okay, I'm here. Yeah. Woo! Okay, now where's the other one? Where are we? Oh, hi! Oh. My sister was getting rid of her PS2. This was one of the games she gave me. Oh, that's such a nice sister. Here you go, little bro. Or actually, misgendering, sorry. But, like, if you are a little bro, then little bro. Here you go, sibling. What is this? Oh. But yeah, here you go, sibling. Let's, have you play the scariest game in the world. Gotcha. Giuseppe! Where's Thick Mommy Zombo GF? There is no mommy GF in here. There is a daddy. And he wears a giant metal pyramid on his head. Okay. No! EA! That's, Gooey Senpai? That's a friend of mine. His name is Giuseppe. Well, that's his screen name. I know him from the Nyaners Discord that I keep talking about. He's actually the one that, got me started on streaming in the first place. Like, he taught me how to set things up and whatnot. And I am so turned around, I don't know what's going on. Is this not a door? Pyramid Head Daddy. Daddy. Yeah. Wait, hold on. What am I looking at something? No. What is... Gotta step away from my computer, but I'm leaving your stream. Well, I appreciate it. Thank you so much. Because again, if I can make this into like a popular place, and I get a lot of people asking questions and yada yada yada, then hopefully I can turn this into a real nonprofit. But we'll see. I was touching the toilet though, and it wasn't saying that I should do anything. So yeah, like I can't interact with the toilet. Like the part where you put your hand in the toilet is like hours before this. I'm feeling this is more like just a place that they discarded. Seducer, gluttonous pig. Alright. Cool. Geez, you really want me to put my hand in a toilet, don't you? Okay, are you right or left? Oh yeah, I mean, that's... It has... Yeah. But that's not one of them. Oh, okay. Hi! Yes, I am so good at aiming and fighting. No. Nope. What about over here? Wait, there was a very scary door. Are you sure? I'm pretty sure I am. Oh, right there. Yep. Okay. But then these documents, they don't do anything. Alright. So... Yeah, that's very true. Okay, so... Okay. Yep, this is scary door that I just walked right out of. So let's go back in. Alright, you bastards, where are you? Okay, I hear footsteps. Says that's... No, that's in Silent Hill 3. Okay, am I at the opposite? Nope, I just turned completely around. Alright. Okay, so those are just inmates above me. Books are scattered all over the bed and floor. On Sacrifice and the Art of Demon Summoning. Home of the Seer. The Feast of the Succubi. The Fallen Angels of Mercy and Favor. Whoa, somebody said something. Okay. Black Magic from the Abyss, Resurrection of the Dead. The Chronicle of Agrippa. Manuscript of the Iron Rings. I guess I shouldn't worry about these too much. Wait, what am I stepping on? Come on. There, okay, there we go. Alright. I would love it if, like, I walked out and then a monster was right there in front of my face. Nope. I didn't want to walk through that door. Alright. Walking all... Whoop. Yes, this is where the handgun bullets were. Okay. Time to leave scary place, yes. Okay. Do. Okay. I guess I... Well, no, there are a couple doors up north that I haven't even tried. So we will go there. So this one... Okay, just completely busted. What about this one? Ah, locked, alright. What about this one? Oh no. So we got a busted desk. The tinkling is probably just glass. Wait a minute. Oh, it's gonna take me to another... Okay, I don't want that. Yet. What about this door? Aha! Here we go. First aid kit. Okay. That's really cool how they, like, let you know, hey, you gotta pick something up, dude. Alright, let's go. Okay. And I just realized this is like somebody busted through visitation. Hi! Visitation hours are over. Okay. Now... Oh, I'm right at the door. Wait. Is it this one? No, I'm pointing at the wrong one. Right. It's this one, right here. And... Oh! Hi again! Wow, I just gave him a warning shot. Nope. Alright, how much do you want to bet that every single other door in here is going to be busted? Except for this one, because it's a double door. Oh, no, it's busted too. Oh. I can't... Oh, now I see you. I got scared by my own shadow. That's why I swung again. I was like, oh, there's another one! Ah, I got an apple. Alright. And right here. Take it up. Thank you, James. Probably a locally published magazine. Toluca Lake, the town's main tourist attraction. This clear, beautiful lake has another side as well. It may seem like just a typical ghost story that you might find in any number of old towns across the country, but in this case, the legend is true. On a fog-bound November day in 1918, the Little Baroness, a ship filled with tourists, failed to return to port. A newspaper article from back then simply says, it most likely sunk for some reason. Despite an extensive police search, not a single fragment of the ship, nor any of the 14 bodies of passengers or crew, has ever been recovered to this day. In 1939, an even stranger incident occurred. And now there are many pages that are torn out. Picking back up, many corpses rest at the bottom of this lake. Their bony hands reach up towards the boats that pass overhead. Perhaps they reach for their comrades. Cool! Ah. Okay, James, what are you looking at? Ooh, handgun bullets. And shotgun shells. And the rifle! What? I don't know. I thought I was going to McDonald's. I thought I was gonna go order. Stuff. Why? Wait. A 20-piece McNugget, no. Hi, welcome to McDonald's. Can I take your order? A large fry and a Big Mac, right? And a 20-piece nugget. Would you like any sauce with that? Oh. Maybe a 10-piece McNugget. I don't know, that's asking kind of a lot. Barbecue sauce. This door won't work. Yeah, okay, good. Why am I saying okay good to being able to leave honey mustard? Would you like to try some dessert with that? Okay. Wait. Why am I... Natty? There's a cover on the ground, but I can't open it. There's only a depression left where there was probably once a handle. Huh. So maybe that's how we get out. Okay. Broken. Broken. That door we went through. Not sure if the wait, hold on. Not sure if the McDonald's do it where you guys live, but the offer to 40-piece McNugget with 2 large fries is intended for 2 plus people. Killer deal. Yeah, I imagine that's everywhere. Okay, so there are several doors that we can still check. And they're on my right. PG-13! Oh, a bathroom. Oh, a save point. Okay, before I have to put my hand in another toilet, I'm gonna save. Alright. Turning around. That is a decent question. Okay, I guess you don't have to do anything in this bathroom. It's just... Huh. Hey, more bathrooms. I clicked around everywhere in that stall, nothing happened. Oh. Probably gonna knock on that door, and then someone's gonna knock back. Yep. And then I walk away. Yep! Okay. Yep. That's just like the locker room in Silent Hill 1. I'm onto your tricks game. Okay. I think I've tried every door that I can. Cool. So I have that scary area here to go through. So let's go back to it. Oh. Oh, the shovel it for the... If you have humans that are pooping, like, poops that are big enough that you require a shovel... Maybe it's a prison for, like, the NBA, then. Because you have giants. That's true. Hi! Yeah, actually, no, it's Silent Hill Who. Get it? Because it's... Yeah, I'll shut up. More handful, it's nice. Where's the monster? Oh, there you are. Hi. Okay. Oh, no. No, I didn't want to go here yet. Okay. And plus, who wouldn't poo self being in that place? Yeah. Like, James's pants, just totally brown. From waistband to, bottom of the legs, I guess. I was gonna say sleeves, but I'm pretty sure pants don't have sleeves. Why don't we call pant legs sleeves? I just realized that. Why don't we call pant legs sleeves? That's the first time I've ever, like, asked that question in my entire life. Wow. Okay, that's to go through one of the cell blocks. The secret is Cap. I'm always high. I bet you I need to do this before I return. Okay, where are the double doors? Oh, here they are. Okay. I think this is the graveyard. Yeah, maybe. Was that a horse? I heard that, and I almost, like, screamed. Okay, so I've checked out the perimeter. caught his breath. Alright, so I walked that entire perimeter. So let's see what's in the middle. A lot of really unpleasant noise. Oh. Executioner 1 and Executioner 2 hanging somebody. And it said you could either choose to die by hanging or by being impaled. And we've seen Pyramid Head impale Mary. Not Mary, Maria. Hey, I like that. Oh. I give you blood to atone for the 3 sins, is written on top of the painting. Beneath the painting are 3 square depressions. Yeah, for the 3 plates. But do I have 3? No, I only have 2. Spoilers! Oh... yeah, I know what happens. Okay. Okay, so we have 1 more plate we have to get. I hope you guys are wearing headphones, and like you get the full stereo effect of that horse galloping noise all around you, so that you suffer like I do. Okay. Are there any... Huh. I bet you I could have already opened that 1 door on the floor. Because I have the wax doll, and I have a lighter. So I could have melted the wax to make a handle. And then I can get that last plate. Yep. That, I bet you that is what I gotta do. Where are you? Oh, hi! No visitors after 9 p.m. Where are we? Okay, just run to the end of the hallway. Got it. And... creepy wax doll. It was lying on... combine it with... and use... What? Okay. Also, no backseating, please. Let me look like an idiot on my own. Okay. Did I miss anything? Good. Why does it... Why does it say there's a basement floor? Oh, that's because I'm probably Yep, I'm standing on the stairs to the basement floor. Okay. Nothing there. Oh, and I'm on the... Right. Turn around. Okay, so that lock doesn't work. Did I touch these doors? You sure about that? Yeah, no. Okay, where am I? Okay, I want to turn around. And try this door. Oh, you're back. Hi. Okay. So we got an old TV. Alright. Right here. This... I didn't realize there was a door here. Okay, now I feel more comfortable. Okay. Okay. Anything else in here? No? I mean, I scoured this room before, but we'll do it again. Yep, and we read that. And we tried this door. And I believe this is where I got the rifle. Yep. Okay. So I got the rifle. And that's literally all there is here. Okay. Just some supplies. Okay, so that's everything there. Yeah, if they could even open, they would have had, like, a red mark or something. But, like, the doors were just all... You couldn't even interact with them. Okay. Where am I? Okay, so let's throw down a save real quick. Save point, I think, is... Yep. Okay. Alright, James, relieve yourself. Here we go. No, I don't want to go through that door. I want to go to the other end of the hallway. Turn around. Run, run, run. I feel like the wax doll and the lighter are related in opening that circle's door. But I need something that looks like a handle, I guess. Okay, through. Alright, so I'll go through this cell block again. And I'm pretty sure none of these doors are interactable. Okay, nope. Nope. And here's our last plate. There we go. Alright. Plate of the oppressor. Wait. Wait, am I locked in? Oh. Can't get the cell door to open. Can't get the cell door to open. Was I here? No, I wasn't. More than 36 people at a recital. Alright, 436 people. Possibly. Possibly. Alright. That is a building on fire. Burning Man. Ha ha ha, that's a concert. Okay. That's not freaky at all. Woman in flight. Alright, so that's the last picture. Oh, Rammstein, yeah. Oh, I'm facing the opposite way. Whoop. Okay, so the next door is on my right. Okay. Right here. Wow. They are right above me. Okay. Whoa! Hi! Dude, I just want to check the door. There we go. Alright, and we were in here. Okay. Okay. Alright. Okay, the only thing left to do is to put the plates in, and that'll probably help us open the door. So, let's throw down a save, just to be careful. And the lights went out. Okay. This isn't creepy and ominous at all. At least the save point's still there, thank you. I'll click on... Okay, just to make sure that it is indeed locked, because that's where we came from. And back in. Okay, and then... Oh, it's PC. That is what I am using. Just don't tell anyone. Alright. Ah, here's There's the door. Now, Three square depressions. So... The seductress. Metal tablet with seductress drawn on one side. Found it on the shower. Let's look at it. Oh, it looks like a Mayan drawing. That's cool. Salmon. Gluttonous pig. The oppressor. Huh. Oh, that scared the heck out of me. Whoa, hey. Okay. Gotta line it up. There. Hand up. Is there anything down here? Wait, hold on. 3 ropes hanging from the scaffold. Okay. I don't think it worked. Give you blood to atone for the 3 sins. Wait a minute. So I did it right? No. Hmm. Maybe if I walk around the place again. Okay, so there's nothing here. I'm pretty sure I was able to do something here. The ropes. But I guess not. Okay, hold on. Hold on. Give me a sec. Hold on. Uh... Gallows. Find the horseshoe. I guess it doesn't matter what order they go in. Walk back to the door. So I just need to walk back to the door? Really? Okay, that's paused. And that's why we hear a horse noise. And yet... Oh, because it's on the door! I'm an idiot. Yep. There we go. Okay. I'm only slightly idiotic. There we go. Wait. Did I pass the door? I definitely did. And through we go. Okay. And now... go all the way to the end of this hallway. Nope. There we go. That's how you open a door. And where's the save? It's to my right. Well, my left. And right here. Okay. So. I must leave now. As I said, I had to go grab food, and I promised I would leave by 7 my time. Thank you everybody so much for hopping by. Thank you for the follows. Thank you for watching. Really, it's amazing. It's really awesome. It is literally calling, yes. So, I will be back tomorrow. I don't know exactly what time, because again, tomorrow is Mother's Day, so... we'll see. I tweet before I go, so just follow my Twitter and then you'll know if I'm going live or not. Everyone, have a great night. Have a good Mother's Day tomorrow. If I don't see you, then I'll see you Monday. So yeah, thank you so much, everybody. Good night.